Hello everyone, and thank you again for watching this live event. Here is lesson number 7 from the Java Fundamentals stream, and we have already discussed a lot of things. Now, if you are joining the event live, don't forget that I have a live chat here, so you can ask questions and I will try to answer them as good as possible directly. If you are not watching this event live, you can as well leave questions in the comment section and in the discussion section, or you can follow me on LinkedIn and Twitter and ask questions there, and I will try to make separate videos to answer your questions. Now, of course, if you didn't subscribe yet to the channel, my first advice would be for you to subscribe to the channel and share with others that you know they might be interested of learning more about Java and applications developed with Java. This is not only a channel about Java fundamentals. You know that I have already created a lot of videos there on Spring Framework and on Spring Security as well, and others will come in the near future. So let's start a discussion about the subject of this lesson number 7, and that is the standard for loop. And the last lesson actually we have discussed a lot about the plus plus and minus minus operators for incrementing and decrementing, and it remained in the end to discuss at this time about the standard for loop, and we will take all the details that you need to know for that OCP Level Certification exam. It is really important that you need that you understand and you know all the possible syntaxes with the standard for loop if you attend this exam and you want to pass it and to get that certification. So you will see that in a real life scenario is not necessarily that you will use all the syntaxes that I will present you today. Even I could even say that you are not advised to use them, and that they are not considered to be clean coding big part of them. But if you are studying for that certification, just make sure that you know all the possible syntaxes, because in the questions that you will see, those code snippets will have all the possible syntaxes with the control structures that we are discussing here. So it's not necessarily for a real life scenario. Why I provide you with all these examples is rather for the case in which I expect that you maybe at some point want to achieve that OCP Level certification, and for that you really need to know all the details. So let's just create a normal project and start our first example. And we just create a very simple Java project, and I will use version 12 because this is what I have installed here, and I will always use with my courses the latest and greatest, and this is at this time version 12. Of course, I will tell you which are the differences when needed, because in this case, for example, you only need to know the syntaxes for Java 11 if you are attending the Java 11 exam, and maybe if you are thinking to still take that certification on Java 8, even if it's not my recommendation at the moment, you would need to know the differences from what I do here between Java 8 and what's new from 8 and above. But no worries, I have a video uploaded already there on the channel, so if you are thinking of attending the Java 8 OCP exam and not the Java 11, make sure that you go back on this channel and find the video that describes in detail what is new from Java 8 to Java 11, such that you know the differences, and you can just follow the same stream, but make sure that you also know the differences between Java 8 and Java 11. So Java fundamentals, that's E7, it's lesson 7, and we just go to the source folder. Let's create a main package and then start with the first example. So I have here maybe a package first, just to not use directly the default package. We create the first example file, and of course the public static void main method. And let's see the first syntax needed for the for loop and how it works. And then we will take a lot of more examples to understand all the possible syntaxes for the standard for loop. So first of all, I will just declare a very normal variable of type int in this case, and the syntax for the for loop is by using the for keyword followed by the round parentheses here, in which we will have three parts that are separated by the semicolon operator, and then we have the curly braces for the block of instructions that can be missing in case you have only one instruction, as well as we have done for all the other situations of all the other control structures that we have discussed in the past. So remember that I have said that also for the if else and also for the while and do while. I think the only one that doesn't respect this because that's another situation there is the switch, where you have to cover the cases with the curly braces, but in all the other cases you can avoid using them if you have only one instructions in the block of instructions. And by the way, as I have said also in the other lessons, this is not necessarily recommended. So usually, even if you have only one instruction, use the curly braces, because this makes it easier to read the code. Okay, so first thing that I will do is actually let's say that I don't have a value yet assigned for this variable here, so the initialization will be directly done here in the first part of the for loop. So this part of the for loop is actually executed once at the moment the interpreter will enter the for control structure. So first time you enter the for, just this first part will be executed, and then the second part will be executed as well, that being the condition of the for loop. So for example, I could say here like x smaller or equal than 10, and again, as any other condition in Java, this must be of type boolean, so this must be an expression that evaluates to true or false, and it can't be anywhere around in Java. You can't have any kind of condition that doesn't evaluate to the boolean type. So in my case, this would be a normal condition. And then, because we know about the plus plus and minus minus operators, I can say something like this. Of course, that doesn't mean that you wouldn't be able to simply just declare an assignment that looks like just a normal addition operation, but as you already know that this is equivalent to x++, we will always use the shorter syntax when developing, and this is the way you will also find it usually in the questions in the OCP 11 exam. So here is where you can actually write any kind of instruction, so it's not wrong from the from syntactical point of view to just write x equals x+1, but you will usually use x++, and it doesn't matter actually if you have x++ or plus x in this case, because being that it is the only operation in the expression, it doesn't make a difference. If you don't know very well how this works, just go back to the previous lesson where I have discussed in detail, and I have provided more examples on how to understand these kind of expressions when you have also other operations in the expression. It's really important because there in the OCP exam you will have plenty of questions, and they are not of the most difficult, but they can be very tricky because they require a lot of attention, let's say. And just make sure that you do a lot of examples with plus plus and minus minus if your goal is to attend that exam and to pass the exam and to get the certification. And then inside we can only print x for each execution. So again, I could have avoided to write this curly braces. You can see that the syntax is correct because I have only one instruction here, but even though I will still use this because it's easier to read. And don't forget that kind of way of writing code in the exam. I've told you about when we discussed about if and else, one of the previous lessons. Sometimes you see maybe something like this, and if curly braces are actually not used here, you might be tempted, if the indentation is like this, you might be tempted to believe that both of the instructions are part of the for loop, but actually this is not the case. Only the first instruction here is part of the for loop, and the other one is actually outside. It should have been written something like this, and then it's easier to see that actually this is equivalent to something like this. But in the exam you will find explicitly this kind of indentation in order to fool you, in order to make you believe the result is another one. So make sure that you take into consideration and you are pretty attentive on this kind of questions, because you will find them for sure. So this will just change usually the answer, that the correct answer, and what is the correct output. Okay, now let's go back to the for loop, and let's just add back our curly braces to see it easier. And we know now that when the for loop is executed first time, first of all the first part in between the round parentheses here is executed, so x will be initialized with value 1 in my case. And then the next part that is happening is evaluation of the condition. So the evaluation of the condition will tell us if anything is executed or not. If the condition is false from the beginning, nothing will actually be executed, and the for loop will be completely skipped. If the condition is true, then what's between the curly braces here will be executed, so all the instructions defined by this control structure. And then at the end, after the execution, this part will be executed, the third part between the round parentheses will be executed, and this means in our case that x will be incremented with 1, and then the condition will be revalidated. So if the condition continues to be true, then again the instructions will be executed and the third part will be executed, and then the condition will be again evaluated, and so on until the condition becomes false. And when the condition becomes false, then the for control structure will be skipped, and in our case, being that this is the end of the program, also the program will end at that time. So if we are to just simply run this example here, the only thing that we will see is that this displays in the console on separate lines numbers from 1 to 10. So in the console the result of this are the numbers from 1 to 10. And if you don't see that, you can always, as I've told you, starting from the first lesson, you can use the debugger in order to see this step by step. So just then run with debug, and you have a debugger available in any kind of IDE, and just start with the debug, and then you are able to stop on a specific line or on specific lines, and then just go step by step. And you can see now that x has value 1, and then next step that happens is actually x will be incremented, and then the condition will be validated again, so x will become 2, but 2 is still smaller or equal than 10, which means that in the next step x will be printed 2, and then will become 3. 3 is still smaller or equal than 10, and then 3 will be printed, and then 4, and so on. And at the last step will be actually when 10 will become 11. So 10 is now printed, and now 10 becomes 11, and the condition is no longer true. So the for loop will be completely skipped, and here is in our case where the program will as well end. So this is it, and this is how it happens that all these numbers from 1 to 10 appear here in the console. Now, if we understood the execution of the main, let's say main way of writing this for loop, let's go to the second example. And in the second example, I will try to change a little bit the declaration of x, and instead of declaring x just declaring x before the for structure, I will try to declare x inside the for structure just immediately in the first part of the for structure, so here where the initialization is done. So we can even just copy paste this example, because I will slightly change it, and I wanted to show you exactly how this is changed. So in this case, if you want to, for example, use the x outside of the for loop, so after the for loop you can just simply print x again, and in this case x will be printed as 11, just because this is the last value that happens to be assigned to x just before going out of the for loop. But the idea is that here x is usable, and you can see x is usable, and you can print it, for example, or use it in some other kind of expressions. And the reason for that is that x is locally declared inside the method here. So being declared inside the method, it will be available inside the method until the end of the block of instructions of the method, so even here. Now the problem is that you can have also the situation in which you declare x, for example here. So you declare x inside the for loop once you have declared the variable in the loop, so that would be either inside the block of instructions, or as you will usually see it, for example, if you use it to loop, then it will be declared here in the first part of the for, that is between the round parentheses here. And in this case x will be visible only inside the for loop, so you can see and you can use x here wherever you want, but not after the for loop. So you see that in this case x symbol cannot be resolved here anymore, because now x is considered to be locally declared inside the for loop, which means that this is usable and can be used, and is seen only inside the for loop, and it can't be used anymore outside. So this is a syntax error. So you have to see these kind of situations, because again in the exam, in the questions, in the code snippets, you can see this kind of situation, and you have to know that in this case the code does not compile actually. So the correct answer for such a question would be that the code does not compile, but you can do that. So it depends. When you declare the variable outside in the method, you can use it inside the for loop, and you can use it afterwards as well. But if you declare it inside the for loop, then you can use it only inside the for loop. Oh, and by the way, if you are going to the Java OCP 11 exam, don't forget that you can also declare the variables that are locally declared. They can be declared by using the var reserved type name, and so you can see the declaration like this, or you can see the declaration by using the var word, and both of them are correct. So don't worry, but expect the fact that you will use you will see a lot the var word, especially in the exam, because this is what is promoted now as part of the newest versions of Java. So there will be a lot of places in which you see the var word, and yes, this is another discussion, but you have to know that this can be used locally for almost any kind of declaration. In this case, where always you have something in the right side, such that an initialization, such that the type of x can be now derived from the value that you assign. You cannot, however, have this var word without an assignment, or by assigning, for example, null. And if you want to know more details about var, you can see that I have uploaded a video on the channel only about this var word, so you can review that video where I have put in the same place all the details about this word. Good. Now let's go a little bit further to the third example and see that this is actually, the for is very flexible, and you can use any kind of value here and any kind of condition. So this is why, for example, here I use value x, which initially has the value 1 and it goes up to 10, and then I have an increment here. but you can do the other way around. For example, you can have value x initialized, variable x initialized with value 10, and then you can go up down to value 1, and then let's see how this would look like. So again, you can simply copy paste the example here, and this will be example number 3. And in this case, what I wanted to show you is actually that you can start from 10 and then you can go the other way around. So for example, you can say while x is greater or equal than 1, and then of course you have to decrement the variable, so you have to subtract 1 out of the value of the variable each time of each execution of the loop. So in this case, instead of seeing values from 1 to 10, you will actually see the values from 10 to 1 in the console if you run this example. So you start from 10 and then you are going until the condition is false, so until x becomes smaller than 1. So the loop will actually end when x will become 0 in this case, because 0 is smaller than 1. So in this case the loop will end. And you see here that I have used the decrement, which is actually equivalent to writing something like this. So it's an x equals x minus 1. Good. Now be very careful in the exam, in the questions, for situations in which the loop will never end. For example, it might be that you are very used to see x++ here, and then it might be that in the situation of a specific question the condition is used wrongly with the operation that makes the condition to be false or not. For example, if I keep this logic, but instead of minus minus I write plus plus, then this is actually an infinite loop, because x is 10, and then for each execution, for each iteration, x will be incremented, so 1 will be added each time to x, which means that next time x will become 11, and then 12, and then 13. So this will actually, from this point of view, never come to an end. It will only overflow when it goes out of the entire, but the condition will never become false in this case. So be very, very attentive to this kind of questions. Okay, now if we got used to this a little bit, let's go a little bit further and copy paste this third example and do some changes on the third example to see another syntax of this loop. So what you will actually see, and we have discussed in the first example, that you can have the declaration outside of the for, and then in the for you can just see in the first part the initialization of the variable. You can have also the situation in which you completely take out the declaration and the initialization of the value, and then it would look something like this. And see, this is really interesting, because now you have nothing specified in the first part of the standard for loop. You still have the condition, and you still have the control instruction here and the block of instructions, but the declaration was completely moved outside. So you have nothing here. Is the declaration and initialization are here, but you don't have anything in the first part, and this is still a condition. This is still a syntax that is correct. So what you will actually find out about the for control structure is that none of the parts here are required. So you can miss any of them. You can use, or you can skip using any of these three parts here, and we want to see all these syntaxes here in this video. I want to show you, because you will for sure find this kind of syntaxes in the exam question. So if you attend the OCP level exam, expect that you see all these kind of syntaxes of the standard for loop, even if again they are not necessarily considered a good way of coding in a real life scenario. I would never do this in a real life application. This is not clean coding, but from the syntax point of view, you have to know them, because this is Java, and the exam will test you on Java syntaxes, so you have to know almost everything in those Java specifications about the Java language in order to have a good mark in the exam and to obtain that certification. So I took out the X, and now let's create another example, the fifth example here. And again I will actually change this again. So instead of having the third part here, that's the instruction that makes sure the condition will become false at some point in time, I will simply just put this inside the block of instructions. And now you see that I even have this situation in which neither the first neither the last part of the for control structure is mandatory. It's simply that I have only kept here the condition, and everything else is outside of the for loop. And you can do something like this because, as I have said, none of these three parts are actually mandatory. So if you run now this example, you will see that I haven't changed the logic. I still have the same logic in my execution. So still the for loop will simply print the numbers from 10 to 1, but it looks kind of different, and we have learned that you can write such syntaxes. And now I hope that when you will see them in the exam, it's nothing new for you, and you know that this is not a bad syntax, so this will actually compile and this will actually work correctly. And we can go, of course, a step further and create example number 6, in which I will completely take out the condition. And yeah, because I can. And you have to know that even the condition is not required in the standard for loop, and in case you don't specify the condition, then this is default true. So it's equivalent to writing something like this. And you can write something like this, for example, so for, and then the condition that is always true, and that is equivalent to not having actually at all specified the condition. So you can avoid specifying the condition completely, and this is equivalent to a condition that is always true. And yeah, this will create an infinite loop actually, but you can come and you can, for example, control the structure from inside using break and continue. So the same break and continue that we have discussed previously in one of the previous lectures, I think, when we discussed about the while control structure. The same break and continue work with do while as well, and the same break and continue work with for as well. So they are the same rules. I won't take them again. If you need to review them, just go back to the lesson in which we have discussed break and continue. But for example, in this case, I can say something like, if x is 0, then break. And this means just get out of the control structure if x became 0, and that's more or less equivalent to what we have previously done, so to all the other examples starting from the second one. So of course you see that it looks a lot more complex. It does the same thing, and it's just much easier to see it like this, for example. Yeah, this is from 10 to 1. So starting from the third example, we have actually done the same thing but much more complicated. So we just changed it step by step. I took out the first part, and I have proven you that you can do that, and then I have taken out the third part, and I have proven you that you can do that as well. And then I took out all the parts, and I have proven you that actually none of these parts are required when you write the standard for loop. And you can write something like this. And if you if this starts to be difficult to understand, again, my advice is just use the debugger. So just start it with the debug mode and see what happens. Go step by step. You will see that we actually enter here the for loop. The condition is always true. That the fact that here the condition is missing, it means that it's always true. And then you print x, which is 10. X becomes 9. 9 is not equal to 0, so it will simply go on and print 9, 8, 7, 6, 5, 4, 3, 2, 1. And when x will become now 0, so from 1 x minus minus will make that x will become 0. 0 is equal to 0. So next thing that will happen is that being that the condition of the if control structure is true now, it just entered the block of instructions of the if, and now it's executing the break. And you know that break means that it will simply go out of the control structure, so it will go out of the for. So that means that we'll reach the end of the program in our case, because we don't have anything else after this for loop. So this is actually how this is working. And now I believe that you also understand why we don't use this in a real life scenario, and we actually in a real life application we just want to have the code as simple as possible. If the code becomes too complex, then it becomes also much more difficult to understand, and then it leaves more room for errors, and we want to avoid mistakes and errors, and so we just try to use the simplest syntaxes possible just to avoid making errors because of the difficulty of reading our code. This is why we are not using, for example, as I have said in the previous lesson, the plus plus and minus minus operators together with other operations in the same expression. Even though you will find that and you have to know how to interpret that for your OCP 11 exam, you should avoid that in a real life scenario, as you should avoid writing this kind of control structures where you don't specify, for example, the condition or one or each of the parts of the for control structure. So just you have to understand, you have to know the syntaxes for your exam, but just at the same time you have to avoid them when you work with a real application. Okay, let's go even further, and I will actually show you that we didn't finish with this for loop. It holds one more secret, I believe, that we have to discuss. And let's create a next example for this. So it's example number 7, and then the main method. And what I want to show you is that starting with the first example here today, I've shown you how to use the first as well as the last part of the for to declare one initialization as well as one instructions to control the condition, but you can have actually multiple. And again, in a real life scenario you won't do something like this because it adds too much complexity, but the idea is that you actually have to know this is working, and you have to know the syntax as well. So for example, I can write something like x is 0 and y is 10. So this is the first part, and you see that if you want to do something like this, you have to separate the declarations by using a comma here. So this is a correct syntax at the moment. And then you can continue with having a condition. You can have only one condition, but you can always use the and or operators to concatenate more Boolean expressions, but you have to have in the end one expression that evaluates to true or to false. You can't have more than that separated with comma. This is not working for the part of the condition. So you always have to have one condition, and that would be, for example, I can write something like x smaller than y. So for example, in this case, this is just a nice normal condition that evaluates to true or to false. And then again, I go to the last part, and I want to show you here that you can actually have multiple expressions here as well. So you can say yes, and I want x to be incremented, but I want y at that time to be decremented. And again, be very attentive at the syntax. So again, the parts are these that are separated by the semicolon. So this is one part, and when you have multiple expressions, you have to separate them by comma. and then in the last part as well, this is the last part, and when you have multiple expressions you have to separate them by comma. So then you can even write something like this, and for example x plus y, and then you can simply execute and see what's happening. Now each time x will become smaller, x will become greater by 1, and y will become smaller, so this will simply print each time 10. That is because 0 plus 10 is 10, but the same will happen when x is 1 and y is 9. 1 plus 9, and then will be 2 plus 8, and then will be 3 plus 7, and so on. And this will actually end when x will become greater or equal than y. It will actually happen when x and y will be both of them 5, because at that time 5 smaller than 5 will be false condition, so the 4 will end at that time. So if you want, again, you can simply use the debugger to see this step by step. Always when you feel that you don't understand something very well, how it is working, just make sure that you use the debugger and you see this step by step. It's very important that you understand very well the syntaxes, simply because when you will be in the OCP level exam, you don't have any kind of I know colors like in the IDE. You don't have any kind of debugging possibility. You only have a code that is written black on white, and sometimes is poorly indented and poorly organized just to make you I don't know, to fool you and to try to make you do more errors. So make sure that you really understand all the syntaxes very well and that you can interpret them when you can see them even on a white piece of paper. That's your goal before going into the exam. So you can see now that x was initialized with 0 and y is 10, so x is 0 and y is 10, and then will be 0 plus 10, and then in the next step x will become 1 and y will become 9, because y is decremented while x is incremented, and so on. This will happen again and again. Always the sum will be 10, because we simply just take out the 1 from one side and put it in the other side. Now the sum will not change by that. And at the moment x and y become 5, both of them, then the condition is false, and then the program will end. So important here is not actually what this for is doing, because it can be made to do anything. When you will see this in your OCP level exam, maybe it will be some other kind of logic you have to interpret, but you have to know actually that this is possible, and knowing that this is possible, you can now understand step by step. You can interpret and understand any kind of algorithm that would be here implemented and that you might encounter in your exam. So this is again maybe the most complex way of writing the standard for loop, where you actually can see that you have this possibility. So one important thing also is that if you have a compound declaration, so like you have multiple declarations here in the first part, in this case you can't use the var word. So you can use the var word with the standard for, like I have proven here, but just when you have only one declaration. If you see that in your exam question you have multiple declarations, this is not possible. You can't use the var word. You have to specify the type in this case, like I have done here with this int. It's important for you to know, because you will see this kind of syntaxes again in your exam. So make sure if you have more declarations here in the part, then the type must be precisely specified. You can't use the var word anymore for that. And this is more or less everything that you need to know about the for loop. We still have one more kind of for loop that we call enhanced for, but we have to wait to discuss first about the arrays chapter, before going into that control structure. So before going and discussing the enhanced for loop, and the enhanced for loop actually looks something like this. It has only two parts that are separated by the column in this case. I will explain this kind of for immediately after we discuss about the arrays, because this kind of for is actually designed to be able to parse collection type values. So for this kind of for, this was what I have planned for you for today, this kind of for, and the other one we will discuss after the arrays chapter. Now, because we still have some time and we have discussed everything that is needed to be discussed about the standard for loop, I think there are no more details that you can find in your exam that are important from the syntax point of view, at least. Of course, the algorithms and the logic that will be implemented can be another one. And I have also told you that you can use the break and continue. You know that break and continue can be used with labels. We have discussed this. They work the same as for the while loop, as we have discussed them in the one of the previous lessons, so I won't retake that. So if you want to recap them, just go back to that lesson, and the same way, with the same rules, they work with the for loops as well. Let's now go to the next example, and I will show you the operators that you can use to make some kind of auto operations a little bit shorter. They are very similar to the increment and decrement, but you can use them in some let's say other kind of expression. So example 8, and we declared the main method here as well. And you already know that we have discussed about this kind of expressions in which you write something like x equals x plus 1, and you know that this is equivalent to either writing x plus plus or writing plus plus x. And all these facts, we have discussed all these possibilities of writing and finding this in different syntaxes in the previous lesson. And the same we have discussed for the minus. So we have plus plus and minus, minus the increment and the decrement operators that can be written after the operand or before the operand, and depending on that we can have different results. Everything is in the previous lesson. Now what I want to show you is that this kind of expressions can also be written with these operators. So this is just a shorter way of writing the same thing as here, and basically this works not only with one but with any kind of whatever you want to add here. So for example, we can just declare a y, and it doesn't really matter. It can be a fixed value or it can be a variable here, but you can have something like this: any kind of expression of type x equals x plus y can be written like x plus equal y. So these two are actually equivalent. This is equivalent to this one. Similar as for the plus plus and minus minus operators, this imposes that x is not a constant. I know that we didn't discuss about constants yet. We didn't discuss about the final modifier, and this is one of the things I promise I will explain better in one of the next lectures. But the idea is that this final here, for example, would create declare that x cannot change its value from now on. So from the assignment of 10, that is the only value that x can have, and this one cannot be overwritten anymore if we use this final word here, and this is called a constant. And if I would have something like this, you can see that neither of the first or the second way of writing can work, because this is exactly what final means, that you can't change the value of x. So this is easier to see here that you change the value of x maybe, but it's a little bit more difficult to see with this expression. But this being equivalent to x equals x plus y, this is also wrong syntax here, because you just try to change the value of a constant, which is not possible from the constant rules point of view that we will discuss in the future. And it was actually, I can leave it a little bit more like this, and it was actually the same thing happens for plus plus or minus minus. You can't use plus plus or minus minus together with a constant. And I think just the last time we have discussed, I have even told you that you will find situations in the exam where you can see syntaxes like 5 plus plus, and it's clearly that 5 is a constant. That doesn't make sense, because this would mean it's equivalent to something like 5 equals 5 plus 1, and this is really wrong. But you will find this kind of syntaxes in the OCP 11 exam, and you must be aware of them before. Okay, now we can remove this and come back to a normal syntax. And just wanted to tell you that you can do that for as well for example for minus. You can find some kind of multiplication done like this, division, or even the modulo operator. So any of these can be used, and simply they are equivalent to, and we can just add the equivalence here to make sure that we have it. And this would be equal to x is x minus y, and this would be equivalent to x is x times y, and this would be equivalent to x is x divided by y, and again the last x modulo y. So not only in the exam, but also in real life applications, in real scenarios, you will find the case in which these operators are used, and this is because it's always easier to use them. They are much shorter. You can see the difference in the syntax. They are much shorter, and it's much easier to just say x plus equal y than saying x equals x plus y. So it's some kind of a repetition here that is not necessary, and we can consider this to be boilerplate code. So the boilerplate code, as you will see in future discussions, this is this kind of code that you can and you can anticipate, you can understand it even if it's not there. So it's better that you simply avoid to write code that you don't need to see, and that's why here, for example, this kind of operator simply remove the necessity of duplicating that x there. So you write a shorter syntax that does the same thing, and it's easier to read, and that's why we prefer this kind of operations, this kind of writing above the one in which we say also we repeat the name of the variable to which we assign. So this is pretty easy as well, you can see. And of course it's maybe not need to tell you that you can do the same thing here. So for example, you could have written x plus equal 1, that would mean the same thing, or you could have written x plus equal 2, which would mean that you add 2 by 2 now to x, and that will actually change the way this for loop will work. So in this case, yeah, you see that in the console we don't have that many values anymore, and there are totally other values, because now if you run them step by step, you will see that each time we add 2 to x instead of adding 1. So the way it was happening when we had that plus plus, or when we use the x plus equals 1, for example, which means the same thing, and when we have 10 5 times displayed in the console. Okay, this being said, I think I have managed to cover what I meant to cover for this lesson, and in these 8 examples now you have all the needed syntaxes for the for loop. We have covered a lot of things about control structures, almost all of them. The only one that remains to be discussed is that enhanced for loop, and that will come immediately after the arrays chapter. So starting with next lesson, we are actually diving again into classes, and we will find a lot of more things and details about object-oriented programming. We will have to start to discuss about overriding, overloading, polymorphism, and other important things to be known by you about object-oriented programming, and we will prove them with Java. These things are really important, not only for your certification exam but also for working in a real-life application. You can't develop in a real-life application and you can't understand the behavior of an application if you don't know very well the rules for these things that we will discuss. And this is why I really advise you to attend these lectures, and if you attend them live, you have the opportunity to use the live chat and send me questions live, and I will just at that time answer your questions. Of course, there is also the possibility that you ask me in the comments and the discussion section, but that would mean that you will have to wait a little bit more because I will have to answer you in a separate video. So that's why if you really are a beginner into this, it's really recommended for you to attend live, so that you make sure that if you have any misunderstanding, you will have the opportunity to immediately ask the questions, and I can immediately answer your questions and create some more examples for that kind of situation. Okay, this is it for today. Thank you again for attending. If you are watching the recorded version, don't forget that you can ask questions in the comments and in the discussion section. You can as well follow me on LinkedIn and Twitter, where you can ask more questions as well, and I can answer you in separate videos. Don't forget that you can subscribe to the channel in order to be notified about the new videos. You can follow me on LinkedIn and Twitter, where I always post messages, and I always add posts whenever I add a new video related to any kind of the subjects that I create videos for this channel. And yes, you can anytime share this channel with anybody that you believe is interested, and yeah, this way maybe we manage to share free Java for everyone and make this language a little bit more known than it is now. It's one of the most used languages on the planet, but we can always help others by doing this kind of videos and tutorials, so that everybody, some more people understand more about Java and examples. Thank you very much, and see you soon.